Okay guys, so today we're going to just review a few things about chemical reactions. The thing you're going to need for today is actually the digital workbook for chemistry. Okay, so again in the class work tab, okay, under worksheet packages for students, right, you're going to need the one for chemistry. And we're going to be looking at page 8. Okay, we'll be starting on page 8. That's where we'll be working on today. So I just want to kind of review a couple of things with you before we get started on that. Okay, so the things to review here. If I'm going to do a question where I'm being given the formula equation, okay, what I'm going to be asked to do is write it in words. I'm going to be asked to identify the type and balance it. Okay? There's not really an order in which you have to do that. Okay? It really doesn't matter. You can do the balancing first or the type first. It makes no difference. Just things to remember. When I'm looking at my reaction, I have to know the patterns. Okay? That is one of the big things that you need to practice / memorize today is the 5 reaction patterns. Right? So if I am looking at a decomposition reaction, I would be looking at something like number 1, okay, where I have only one reactant and it's breaking down into its 2 elements. Okay, that is the only reaction type with only one reactant. If I am looking at a reaction like number 2, right, where I have an element reacting with an ionic compound, I am looking at a single replacement reaction. And that element will replace the part of the ionic compound that it is like. If I'm looking at a reaction where I've got some compound that is carbon and hydrogen, and it's reacting with oxygen, it's a combustion reaction. The products of a combustion reaction are always the same. They're always CO2 and water. Okay? What we have to remember about combustion reactions is that they have their own rules for balancing. Okay? We have to balance in alphabetical order and the rule of 2. So if there's an even number of carbon atoms, then we start our balancing with a 2 at the front of the reaction. Okay? So just these little rules that we have to practice and get used to using. What kind of reaction would number 4 be? Synthesis, yeah, okay, it's 2 elements, they're going together to form a compound, right? For all the reactions except combustion, what's our rule for balancing?
Start at the largest number.
Start with the largest number, go from there, okay? And then for number 5, okay, we've got an ionic compound, they're all ionic compounds, that's a double replacement reaction. So each reaction has its own unique pattern, and you just have to become familiar with them so you can recognize the patterns. Okay? All right. So if we are looking at, okay, this is the one that you guys are working on right now. Okay? Number 1 is done here, but I'm going to just walk through it with you. Okay? It's not done on yours, so if you're looking at your digital workbook, this is the answer for number 1. Okay? So on number 1, I've got iron, and it's reacting with hydrogen chloride, and that's going to produce iron 2 chloride and hydrogen gas. Right? So if I'm going to write that out in words, obviously I write iron for Fe. Okay? Hydrogen chloride is an ionic compound, so I would write it according to the ionic rules. Write hydrogen unchanged, chlorine ending in "ide." Then I have FeCl2. Since iron can have more than one possible charge, I have to figure out which Roman numeral goes in there, put it in there, iron 2 chloride, and hydrogen when it's an element looks like that, H2, so I just write hydrogen for that. And that is a single replacement reaction because it's element reacting with ionic compound. All right, so that's all, and then we have to balance it. So if I'm looking to balance this one, I would start with either hydrogen or chlorine. They're the ones that are out of balance in the biggest numbers. So I go back and put a 2 in front of hydrogen chloride. That gives me the 2 hydrogens and the 2 chlorines, and everything else is a 1. Okay, so we're just practicing that today. I'm going to give you a bit of time to get ahead of me, and if there's any that are giving us trouble, I'll go over ones that you request. If you don't request any, I'll pick some. And we'll go over. I think there will be some requests because there are a few reactions in here that are a little bit tricky. Okay? Now, I'm going to post the key shortly, okay, so that you can check your answers as you go. Okay. All right, have at her there, guys. Okay, so guys, a good question just came up here, and it was one of the ones I thought would come up, and it's on numbers 8 and 9, okay, from the first sheet here, okay, and it's about reaction types for those two reactions. Okay, they don't exactly fit any of the patterns that we've talked about, but they are both synthesis reactions. A synthesis reaction is not always two elements combining to form a single compound. It is always two reactants forming a single compound. Most of the time that happens to be two elements. Okay? But in this case, we still have synthesis reactions because there are two reactants and only one product, and that is the true pattern for all synthesis reactions. Okay? So they don't exactly fit the pattern we talked about because we simplify it a little bit. Okay? Those are still synthesis reactions. All right? And they're going to be a little bit trickier for your balancing. Okay? What you have to remember about both 8 and 9 is that oxygen is in every one of your compounds, and that you need to make sure what's left of the arrow equals what's right of the arrow. Okay? So you gotta think about that. It's a little bit of math trickery, actually. Okay? But you guys can handle it. I'll do that one in a few minutes. Are there any other ones that are giving us questions or that we should go through as a class? Okay. 8 and 9 were the first two I was going to go over, but I'm going to give everybody a chance to kind of get there first. Okay. I'm going to be posting the key here right away. Okay, so as we said, 8 and 9 are both synthesis reactions, okay, because they are two reactants combining to form a single compound. Right? When we want to balance this, right, what I have to consider is that I have oxygen on both sides, and I have to balance the total number of oxygens over here with the total number of oxygens over here. Okay? Now, what I'm looking at is that I've got 4 oxygens on this side, and I've got 3 oxygens on this side. What's a number that both of those will go into? 12. All right, so what I'm going to do is I'm going to make sure that I have enough sulfur over here, or sorry, enough SO3 over here, sulfur trioxide, to make 12 oxygens. Now I'm going to go back over here. When I put that 4 in front of the sulfur trioxide, it also gave me 4 sulfur. So I'm going to go back over here and put a 4 in front of the sulfur. So now I have 8 oxygens here, and I need to get to 12. So I need 4 more. So what do I need to put in front of this to get 4 more oxygens? A 2. All right, now this is balanced, but what can I do with all those numbers? Reduce them. I can reduce them, and I should. Okay, whenever we're balancing and we can reduce, we should. Okay, so this should actually go down to 2, 1, 2, and it'll still work. All right, I've got 6 oxygens over here. 2 times 2 is 4, plus 2 more is 6. 2 sulfur, 2 sulfur. The equation is balanced. Okay, so this written out in words would be sulfur dioxide plus oxygen gives sulfur trioxide. And number 9 works very similarly. Okay, on this side, I've got 2 oxygen atoms, and over here, I've got 3. Okay, if I run into an issue like that, where I've got an odd number on one side and an even number on the other, and I had the same problem up here, okay, basically I just need to double the odd number. Because if you double an odd number, you always get an even number. Okay, so if I put a 2 in front of my carbon here, right? Now I have 2 carbons, so I have to put a 2 over here to balance my carbons, okay? And now I have 4 oxygens. 2 plus 2 is 4, and I'm done. Okay. That one's balanced as well. Right? So if you ever run into a problem where you've got this, and it's usually oxygen in like every single compound, and there's an odd number on one side and an even number on the other, double the side that's odd, and it'll fix it almost immediately. All right, keep going there, guys. How many people have done all 13 of those? Okay, getting close. All right. If you're done all 13 of those, go on to the ones that are, I give you the word equation, and you have to go to the formulas, because those are trickier, okay? And especially in terms of getting the balancing right. Track. Okay, so for number 1, I've got magnesium and chlorine produce magnesium chloride. So when we're reading that as a sentence, the and means plus. So magnesium is Mg plus chlorine. What do I have to remember about chlorine when I write it in a reaction from words? It's a 2, right? It's one of our special elements. If I forget that, I'm not going to balance this reaction correctly. And that's going to produce magnesium with a 2 plus and chlorine with a 1 minus. When I drop and swap, MgCl2. Okay, looks to me like it's already balanced. 1 magnesium and 2 chlorines on each side. What reaction type is that? It's a synthesis reaction, right? Okay, so that's all we're looking for those. Obviously, they're going to get more complex than that one. Okay, but I think you guys can handle it. Okay, there'll be a few here that I'll be doing in front of you just because they're a bit tricky. Okay, so keep working on them here, but there's a few that I think you guys will want me to go over right, as you move along here, so don't be afraid to ask. So first one I want to look at is number 3. Okay, so if you're looking at that one here, we got aluminum, okay, which is Al, reacts with oxygen. We have to remember oxygen is one of our special elements. It's a 2, okay, and that's going to produce aluminum oxide. Aluminum is a +3, oxygen is a -2, and it's an ionic compound, so we do have to drop and swap to get Al2O3. This one's actually wrong on the handwritten version of the key, and that's why I'm picking to do it, because I messed it up, okay, on the key. So in this one here, now we need to balance it. Oxygen is present in our highest number, but it's an odd number on the product side and an even number on the reactant side, and we said if we have that problem, we should double the odd number. So now I have 6 oxygens, and I can put a 3 here, and I have 4 aluminum, put a 4 there, and now it's balanced. What kind of reaction is that? It's a synthesis reaction. Okay, so that one's a little bit tricky with the balancing. And then we got, I don't know, which one was I looking at here? Which one it was now. Oh, sorry, it was number 2. Okay, sorry, it was number 2. So we got dihydrogen monoxide, which is a fancy way of saying water, okay, is giving off or decomposing into hydrogen and oxygen. What do I have to remember about both of those? They're both special. I know that hydrogen is not highlighted in yellow on your periodic table, but it is listed on the top right-hand corner, okay, along with the other ones there. Okay, and the reason is if I tried to make it yellow because it was already dark, it kind of messed it up. Okay, it just kind of didn't show up very well. So hydrogen is also one of the ones that comes as a pair. So we're looking at this, and then we have to double the side of the equation that's odd, right? That's going to give us this for our answer there. So we got to remember, okay, that hydrogen is also one of our special elements. Okay, any other ones in this set giving us trouble that we want to go over? How many people have done all of them? Okay, so 1 or 2 of you. All right, let's take a little break here. Let's say we'll break until 9:48, okay? And then I'm gonna have you look at some trickier balancing stuff after that. Okay, on this next sheet that you guys have, right, there are a few reactions that are a bit more balancing intensive, right? You don't have to write anything out in words, you just have to identify the type from H on and balance them by filling in the blanks for all the rest, right? But it's a good exercise for us to practice our balancing, which I find tends to be the tougher of the skills, okay? Because for me, naming is just naming, right? Identifying the types is just recognizing a pattern, but every reaction is a little bit different when it comes to balancing, so they get a bit tricky, especially as we go along here and we get into some of these double replacement reactions, okay, where we got polyatomic ions and all of that kind of stuff. The balancing becomes a bit more adventurous, okay, we'll say. But you would be expected to balance reactions that are that complex. The ones we've worked on thus far today have all been relatively simple. A lot of synthesis reactions, a lot of decomp reactions, not a lot of replacement reactions, and no combustion reactions. Okay, we haven't done any of those yet, right? And there aren't any combustion reactions in here either. All right, that's a totally different thing. In fact, maybe before we do these ones, we should just have a quick look at a couple of combustion reactions here. So I'm going to write one in words and have you write it in formula form, then I'll write one in formula form, have you do it in words. Okay, so so I'm going to want that one written out in words and balanced. Okay, so give those two a try. Okay, so for the second one, it's pentacarbon dodecahydride. Dodeca is the prefix for 12. Okay, so I wrote 12 above it just so there's no mistake. All right, so for our first one here, okay, we've got tetracarbon decahydride, or butane, okay, is reacting with oxygen gas to produce carbon dioxide and water. That's what it would sound like in words. Okay, we need to balance this reaction. So I got to balance it alphabetically. Do I need the rule of 2? Yes, 4 is an even number. So I start with a 2. All right, now I balance in alphabetical order. 2 times 4 is 8. So I put an 8 here. Okay, now I do the hydrogens. 2 times 10 is 20. 10 times 2 is 20. And now I do the oxygens. There are 16 oxygens here, 8 times 2, plus another 10 more is 26. 13 times 2 is 26. Okay, write it out. For the second one, we have pentacarbon, so that's C5, dodecahydride, H12, right? Reacting with oxygen gas, O2. And that is going to produce carbon dioxide and water. So writing these ones out in formula form is quite a bit easier. There's no dropping and swapping, no Roman numerals or any crazy stuff to do. You just write them out. So obviously it's a combustion reaction and I need to balance it. Do I need both rules for this one? No. 5 is an odd number. Okay, so I don't need to start with a 2. So balance alphabetically. There's 5 carbons here. Now there are 5 here. There are 12 hydrogens. 6 times 2 is 12. And now for the oxygens. 5 times 2 is 10 oxygens here in the carbon dioxide. plus another 6 more in the water for a total of 16. 8 times 2 is 16. All right. So we're going to be working on some trickier balancing stuff tomorrow. Then you're going to have a week off. Then, when you come back, we're going to look at predicting the products of a reaction. We're going to work on a little research project for this unit on a toxin of your choice, so you can think about that. We've got to research a toxic chemical. And then we're going to do our reactions lab. Okay.